When ParallelCluster was born, it made sense to spin up bits of block storage, attach them to the head node, and NFS share that to the compute nodes. It's probably the most vanilla HPC architecture in the book, and it made sense at a time when the main storage system types here at AWS were block storage, Amazon S3, and a small handful of other things really designed for mainstream computing instead of HPC. So we rolled our own NFS shares, tuned them quite a bit to make them scream, and supplied /home and lots of things from /opt to the compute nodes. Now, when our friends at the storage team came up with Amazon FSx for Lustre, and that's a few years ago now, we did exactly what good HPC nerds should do. We quickly set it up from scratch and made stuff run fast, really fast. And so we entered the main sequence of ParallelCluster's life, where lightweight things like home and /opt were shared using NFS from the head node, and heavy-duty things used Lustre.
The thing is that design is really cool because it lets customers just get going with a cluster. And if your cluster is ephemeral, if you really understand your utilization and your usage patterns, then that's absolutely fine.
And customers did indeed get going. They got going with so much gusto that we now have customers who spawn new clusters half a dozen times a day. Yes, that's weird, but this is the cloud. You don't have to build these things by hand like your grandfather did. And, well, that's why weird is normal here.
And the other thing is that especially if you're in a multi-user environment, people put really important things in their home directories. Their configuration scripts, software installs, job scripts. The really important thing, your dot files, critical to your day-to-day existence. Well, the challenge is when you upgrade pCluster, you have to tear down the head node. And that all those user home directories will go away unless you do some heroics on the EBS volume. The other thing is if your head node crashes particularly hard, bad day, at the instance factory, that data could become unrecoverable.
So, cut to today, and we've just launched ParallelCluster 3.9, which lets you decouple these important chunks of the file system from your head node, so they can exist on another service you may have heard of, Amazon EFS, the Elastic File System. Now, EFS is basically a huge NFS filer. You can ask EFS to provision you a new file system for whatever you need. You only ever pay for the storage you actually use, not the storage you are yet to use. So it's a different NFS experience from the start.
In your ParallelCluster configuration, the head node section now has a shared storage type setting. It defaults to EBS, and if you just leave it there, then those NFS shares come off the head node, etc. But if you set it to EFS, then instead of running the NFS shares from the head node, pCluster provisions an EFS file system and uses that for opt ParallelCluster, opt Slurm, opt Intel, and /home. And that's great because now all the sizing and system performance scaling gets handled by Amazon EFS. And that's a whole team of people and capabilities instead of your homegrown NFS server.
That's cool because once you do this with your cluster, no user with a pathological job is going to be able to hammer the head node so badly that it melts and the scheduler function gets impacted. But this isn't all we did.
You can now define /home as a mounted network volume. And there you can bring your own EFS or FSx file system. And that means that those user home directories exist outside the cluster lifecycle.
That's right. So if you define your home directory in the head node section of the config file to be an EFS volume, and then subsequently define /home in your shared storage section by referencing an existing EFS system you use for home directories, then ParallelCluster will use the /home you provided cluster-wide.
And by the way, it's really easy to do that because, you could just be a pro at EFS and FSx provisioning, or you could use the HPC recipes that we publish for standing up, ready to go EFS and FSx file systems. So basically, all you need there is the ID and a security group, and you're ready to go.
And that's it. Sometimes the coolest features are the ones that don't need much explaining and aren't rocket surgery. If you enjoyed this tech short, please give us a like and consider subscribing to the channel. If there's a topic you want us to focus on, reach out to us at askhpc@amazon.com. We want to make it easier for scientists and engineers to solve the world's hardest problems. We think the cloud can help by giving them access to powerful tools of any shape and size whenever they need them. And that's where you come in. Let us know what you need. We'll see you next time.